Chris, what I'm going to do now is open up EasyScan so you can see the client software.
Chris, what I'm going to do now is open up EasyScan so you can see the client software.
Machine. And we'll pull up EasyScan right now. So this is the client software, and this is the window, which you'll see, the model window. I'm going to connect the scanner right now. Now, what you're going to see in the corner here, I'm going to maximize this for you so you can get an understanding of what we're looking at here. So right now, we're looking through the cameras, and we see a left and a right image of this, and you can see there's a shift in each of the objects. That shift is what allowing the cameras to read that pattern on the surface and give you the three-dimensional data. So I'm going to start the process. If you look down at the lower left-hand corner, you're going to see a number of buttons here. These are going to swing and rotate the table. And we'll talk about this later on just a little bit, but you can program this. You can write these little macros for yourself or use the ones that are embedded in the software. It's customizable, and you can customize it for a particular object shape or a particular style of something. So I'm going to hit P2, and the scanner is going to start, as you saw in the video, and as it scans, you're going to start to see the data appear in the viewport.
This is really where the magic is in this machine. It's just extremely quick in gathering all this data.
So the machine is swinging, and so now if you look at the lower left-hand corner, you'll see there's a number, and then there's a swing, and then there's a rotation. So what it's doing, it's positioning the part so it can capture each part, and it rotates, and it might do, you could see it's 0 swing and 90 degrees or negative 180 degrees. So it's each time it's doing this, it's capturing a snapshot. If you look at the right-hand side of the screen, you'll see it says model 151029, and then underneath that there's a group. Each one of those is an individual scan. So what the software will do, it'll do this a number of times. I believe there's about 22 scans on here. We'll let it go until the end. I'll do another one to show you a reposition and do another one, and then I'll switch to another file to show you the editing process. So again, each time it does this, it's a snapshot. In the case of this ring, to get a closed volume, I scanned it 3 times. I did a vertical scan, as it is, you see it. I rotated the ring forward and then backward and did 2 more scans, and then I turned it upside down in order to get the inside or the pocket of the hollow part of the ring. So with 4 scans and a little bit of time, which is probably no more than about 20 minutes, we had a closed volume, which then could be imported into just about any program. The only thing that was missing was probably a little tiny part at the bottom, which again the software will allow you to close holes, decimate models to make them a little less dense. We can get rid of extraneous data that way just with a couple of button clicks. So we're almost done on this last one. I'll do a couple more. What I'm going to do is I'm going to stop this at this point, and I will go back and reposition the part for you, and then we will start another scan. Okay. So there's our first scan. Again, it's not complete, but that's okay. We're going to show you a completed one and how to edit this. I'm going to move the object forward a little bit, and you'll see this scan disappear, and we'll get another set of data from our system. So we're going to go to P2 again. That will disappear, and now we were scanning the part in a different orientation, which means that a different area is exposed, and we'll get another set of data which will fill in some of the areas. Once this is done, EasyScan allows you to take those volumes and edit them and then align them into one volume. So in the case of things with pockets or undercuts, you can capture that, but it takes a few scans in order to do that. I'll let this run a few more times, capture a little more information, and then we'll go into the edit part. So the software itself is very, very simple. It's standard Windows software. We have everything that appears in the pull-down menu is on the screen itself. We have on the right-hand side, we have edit tools for capturing polys and either deleting them. And then we have moving tools to take the scans and combine them into one scan. Are there any questions along the way with anybody in the audience?
I think so far we've got, we did have one question about how long it took to do that set of scans. It was about 1.5 minutes for that set of macros, approximately.
Yeah, probably, yeah. And again, you know, this is a macro that came with the system. I like it. I use it often, and it just seems to work for me. You can create something that is only, you know, maybe 4 or 5 scans. You can also do manual scans. We won't get into that today, but you can take individual snapshots or align the piece to get a part of the object which didn't happen in the original scan. You can do the whole thing manually and take one snapshot at a time and just keep moving your object. So there's a lot of flexibility in the software as far as, you know, allowing you to capture only what you need at any given time. So now what I'm going to do is I'm also going to X out of this as well and stop the scanning process. Okay, so now once that scan is done, you'll notice that we have 2 scans and we have one on top of the other, or overlapping. So there's also extraneous data from the table. Now, the newer system has fixturing devices. I tend to use just a white wax for stone layouts. For me, I find that it's not picked up by the system, and it makes editing a lot easier for me. But again, you'll work out your own ways of holding things down, and the new system of fixturing is really robust, and it helps out considerably. For me, this is just the road I took with it, and it's my way of scanning. So I turned off one of these, and now I'm going to go into the edit tool here and capture some of these polys. So notice that this is part of the table that's been captured. I'm going to go in here, and I'm going to grab that, and it turns blue, and I'm just going to delete it.
Just the lasso tool.
Right, it's just a lasso tool, and now I also bring this into the center of the viewport. If this was off to the side a little bit, for instance, I would know that I have some data I have to look for and get rid of. So there's one scan, and I can also turn these off as individual scans or turn them on. So each one of these, again, is a snapshot for the ring. And so if there's anything that doesn't look like it registered properly, you can delete it and get rid of it. So, you know, you don't have to use everything. You can use only what's necessary with these scans. I'll turn the second one on as well, and I'm going to edit that. So in this case, I moved it forward. I'll use my lasso tool, and I'll go around and just capture a bunch of stuff here. Delete that. That there. And now I will zoom this to the center. So that looks pretty good. I probably would have to go in and clean that up a little bit with some other cleanups. But now what I'm going to do is open up the file and show you how to align these objects. So I have a previously done file here, which will open up. So the editing process is very quick, and also the alignment process is very, very quick as well. So here are the 4 original scans that I did for this ring. I took them and I moved them out of the way. So now what I'm going to do is turn on the move tool here, and I'm going to that's my first scan that's misaligned. So now by left-clicking and dragging, I can actually rotate this into position. Right-clicking will spin the object, and left-clicking will actually rotate the object. If I press down Control, I can slide this around, move it in a better position. This is view-dependent, so getting it in the, you know, you can use the viewport itself to help you align this. So once we get to this part, I'm also doing it, I'll show you another methodology on the second one. We can also do a triangulation to get this in there. So what I look for, the algorithm and the software really does a great job of aligning. So remember that the closer you get it, the better it is, but you don't have to be perfect. You just have to make sure it's close enough. And it's going to look at the curvature and put these two together. So what I'm going to do now is I'm going to deselect this one. It asks me, do I want to confirm the new position? Yes, I do. And I'll turn this back on, and we'll capture the next one. So this is the one that was an upside-down scan to get the pocket on the inside. In this case, I'm going to try a triangulation. I'm going to use 3 points to align this. I'm just going to rotate a little bit just to make it a little easier for alignment. but it doesn't matter if it's upside down or how it is. So I'm going to pick 3 points on the object to realign this.
This is where you're basically taking multiple scans and lining them up, and you're set
so here,
after that point.
So I'm picking a reference point and a target point on this. And so let's go, and I'll pick on the tip of the ear here and the tip of the ear over here. And then I'll do one more over here and one more over here. And there, I align these up. So it's close enough. It does it very fast. And of course, you can go back in there and do a little bit of a manual alignment as well, which I will do just a little bit of in this case. So once those are aligned, I like what I see here. Let me rotate it just a little bit more. Slide it over. Okay. So now I like the position. I'll uncheck this. Yes, I like it. I'm going to collapse these stacks of scans right here. I'm going to grab all of these together. And I'm going to go over to Tool and Align All. So I want to do it at a high level. And now the software is going to go in and it's going to look at these and it's going to start calculating the curvature and giving me an alignment. So it'll take a little time for this to work. I probably could have got a little closer, but and this is a convoluted piece, so it will take a little longer on pieces that are a little more complicated. But it's moving along fairly well. Chris, you want to add anything?
No, I think your looks great.
Okay, all right. So I just got
answering questions. Kevin Furtenbaugh asked about CPU power, and you know, basically it's not going to be any more than the machine you're probably using for your CAD software.
Correct. I would say that's a safe bet. Sure. What's important here is that the process, once learned, is relatively fast. It's almost as anything else. When you've become good at a piece of software, it's second nature. This doesn't take that long for training, and you know, with a week or two, even less time, you'll be getting decent scans out of this and be able to use that data effectively.
You had just did an install on Tuesday, and literally they were doing scans before you left.
Correct. Correct. So let this work a little more. Again, I apologize. It could have got a little better, but let's see how this works. This can really demonstrate the power of the software and how it can align things. So what I use this for in my business is really for two things. One, I'll capture information from customers to rebuild something, or maybe alter it in some way so that we keep the same design intent and look that they're looking for. So I'll take these objects into Rhino, I'll extract information off that, and then use that to rebuild and reverse engineer things. The other way I use it is to capture things directly that I can take into ZBrush and use that for direct sculpting and direct modeling.
Good example would be, you know, many of the retailers that are listening in, I'm sure, have folks who come in and want to have a piece, you know, either like an heirloom piece, you know, need to be reproduced. You know, now all of a sudden you have a tool that allows you to do that in a much more efficient manner.
It's really been a game changer for me in my business because you know, I can't tell the countless hours over the years I spent writing things down and maybe having an object for an hour or two and not being able to really capture the information or worrying that I do capture the design intent. So you can basically do 5 scans and, you know, archive them and then pull them up 3 months later and have the information you need to at least do the job and not have to worry about, did I get every measurement that's necessary. So we're almost there. Now you saw all those pieces snap together on the screen. So at this point, these are 4 separate scans. We can go in here, we can do editing, we can eliminate some that we don't think are going to work. But at this point, they're lined up fairly well. And it looks a little bit of a mess right now, but the next thing we're going to do is we're going to do what's called a volume merge. Once you do that, you can't go back and edit, so the software is going to prompt me in this case, do I want to save this before I commit to this? So I do that. I usually make a separate file just in case there's any problems. I don't lose my original scan data. So now we were highlighted here on our model group in our stack, and I'm going to go right here now and I'll say Tool, and we're going to do a volume merge. And we'll do this at a high degree of accuracy, which is 0.06, so we're about a half a tenth of a millimeter, basically a couple of thousandths of an inch. No, we don't want to save it right now. And now this is going to be doing a volume merge. At one point, this will turn white in one solid color, and we know that we have a volume. And with a little bit of editing, we can go in there, we can close holes, we can decimate, we can eliminate problem areas, or we can basically just go in and just cut it up into sections if we want to as well. I'll move this out of the way so you can see the final merge. Okay, and there we go. So there's our final model with the details, with all the details in there. The only thing that was missing in here was this small little area here, which was, I think, a piece of the code.